Hi everyone. This is the first in a series of videos about vectors and the basics about vectors. It's also first edition. I'll probably edit this pretty soon. We're looking at vector notation and what is a vector. Vector is a quantity that has both size and direction. Here's a couple of examples. Those three things I've just drawn are line segments, and they all have the same length. They're all 5 units long. But if we consider from A to B as vector B, AB, and then here we go with vector CD, going from C to D, and going from E to F is vector EF. So all of those things are the same length, but they're going a different direction. So they are different vectors. Also got to note that AB equals BA. They're the same line segment, they're the same length, but vector AB doesn't equal vector BA. And we'll talk more about this soon. Why do we need to know vectors? Well, vectors are really important in physics. Stuff like force, acceleration, velocity, displacement, momentum, work, electric field, all have magnitude and direction, so we can all express them. We can express them all as vectors. Things that aren't vectors, that only have magnitude, we call them scalars. Temperature, density, they're good examples. A classic example, speed is a scalar. I traveled at 50 kilometers an hour. Velocity is a vector. I'm traveling at 15 kilometers an hour northwest. Okay, same distance. I went 5 kilometers. Displacement. I am 5 kilometers from where I started. I may have gone a bigger distance, but where I am now is the displacement, the vector. We'll see more of this later. Okay, we tend to express vectors as column vectors. Here's a vector called A, and we write it as 4, 2 in a column vector like that. What's that actually mean? Well, 4 to the right and 2 up. Okay, so the first number, the top number, is the x direction, and the second is the y direction. Here's another example. B, it's -3 because it's 3 to the left, and 2 because it's 2 up. Remember, there's the start and there's the finish. So to get from the start to the finish, you go along B, but that's the same as going 3 left and 2 up. Okay, here's a little quiz for you. Pause the video, see if you can write down what these 4 vectors are. Okay, time's up. Here's the answers. 1 right, 3 up. 2 left, 3 up. 4 right, 1 up. 4 to the left and 3 down. Okay, that's how you do column vectors. Here's some more vectors, 4 more vectors. These are between 2 different points. So vector going from P to Q is vector PQ. It's 2 right and 4 up, so 2, 4. Vector GH is 4, 2. RW is 3, -2. And vector FK is -4, -2. Just an interesting little thing. Vector QP, to get from Q to P, you have to go 2 to the left, so -2, and 4 down, so -4. And look at that. PQ and QP are just negatives of each other. So QP equals -PQ. It works for AF and FK as well. You can see that. Those were all 2-dimensional examples. We can do it in 3 dimensions as well. We tend to use a right-handed coordinate system, which I'll talk more about in a minute. I'm going to use this designation for our Next two examples, x and y axes are like normal, x is horizontal, y is vertical, and z is coming out of the screen. We don't have to do it that way, and I'll talk more about this in a second. Here's a vector v, 3, 2, 4. So that means 3 in the positive x direction, 2 in the positive y direction, and 4 in the positive z direction. So it's coming out towards us and going up. Here's another vector. It's 3 in the positive x direction, 5 in the negative y, so 5 down, and -1 in the z direction means going back into the screen. So that's your vector. Now, it doesn't look real great trying three-dimensional drawings in 2 dimensions, but we'll live with it. I just want to explain this right-hand coordinate system. It's convention that we always draw it according to right hand. If you imagine that your thumb is the x-axis, your finger, first finger, pointer finger, is your y-axis, then the direction that your hand palm pushes is where the z-axis will be. They're always at 90 degrees to each other. Instead of using your palm, you can point your middle finger up, and then that'll give you your 3 axes. The positive x-axis is your thumb, positive y-axis is the pointer finger, and positive z-axis is your middle finger. And they're all 90 degrees to each other. An alternative way, rather than column vectors, is called vector components. Vector v here is 5, 4, 5 to the right and 4 up, from the beginning to the end of the vector. You can also write that as 5i plus 4j. Vector w over here, instead of -4, -3, we can write it as -4i minus 3j. And that's just a different notation. Remember, or note that I is 1, 0 and j is 0, 1. If we had 3 dimensions, we have k as the next little vector, and it would be 0, 0, 1. So here's a vector that has magnitude and direction. Its magnitude is 5 units, is heading northeast. How would you write that in component form, or even as a column vector? Well, let's draw in the components. So 5 units heading northeast is AI plus BJ. Well, going back to really simple trigonometry, A is 5 cos 45. Okay, opposite over hypotenuse is cos. No, adjacent over hypotenuse is cos. Okay, and B is, we're using sine this time, 5 sine 45 degrees. If we sub in the numbers, you'll get that you've got V is 5 root 2 over 2i plus 5 root 2 over 2j. And one more example. We've got a magnitude of 7 and a direction that's south 30 degrees east. So south is straight down, go 30 degrees from south towards the east. That's your direction. Okay, to get the components, again, it's AI plus BJ. But this time, you can see if that's a 60 degree angle in there, you could say that A is going to be 7 cos 60, or you can do 7 sine 30 if you really want. And B would be 7 sine 60, but it's negative because it's heading downwards. And then there's our final answer, that W is not 7 units, not only 7 units south 30 degrees east. It's 7 on 2, negative 7 root 3 on 2. Or 7 on 2i minus 7 root 3 on 2j. Okay, I hope this was helpful. there's many more videos to come in this vector series.